Good afternoon, everyone. Welcome to Summer STEAM Camp. My name is Miss Adrienne. I'm one of the children's librarians of the San Mateo County Libraries. And today we're going to be doing some interesting experiments using yeast. This experiment we're going to do today was designed by the Bay Area Discovery Museum. And it should be appropriate for children in grades 2 and 3. However, younger children are welcome to participate. So let's get started. Anything that you make today or the experiment you do today, if you want to take a picture and tag us, please do, then I can see what you make. This is the tag we're going to check. It's SMCL Creates. So go ahead and tag us if you do create anything today for our during our experiment. Okay. Oh, and then also summer learning is underway, started on June 1st. So if you want to participate in summer learning, you can do so by going to our website at smcl.org and signing up. All participants who finish one reading log are entered to win a $1,000 scholarship, which every year a number of children take home. So I hope that maybe this year you could be the lucky winner. All right, so today we're going to do an experiment using yeast. But before we talk about yeast, we're going to talk about briefly the states of matter. So matter is anything that has weight and takes up space. So this roll of tape is matter. In fact, most of the things on this table are matter, but matter also can include things that we can't see, like molecules and atoms, things that are too small for us to see with the naked eye. It can also include things like yeast. Yeast is a single cell organism that you can't really see with your naked eye, but you can see under a microscope. So matter can be visible, but it can also be things that we humans can't see except with our scientific instruments. There are 3 states of matter. So there is solid. This tape, for example, is a solid. It holds its shape and it doesn't fill its container. Another form of matter is a liquid. So a liquid like this I have in this jar here, it does not hold its shape, right? It takes the shape of whatever container it's in. So if I were to pour this liquid into a circular bowl, it would take the shape of a circle. Yeah. So liquids change their shape depending on what container they are in. The last form of matter that we're going to talk about today that's going to be significant for our experiment is gas. So a gas changes its shape to fill whatever container it's in, and it expands to fill the whole container. So the molecules and the atoms of the gas spread out equidistant from each other to fill the space. So even if we're talking about putting gas in a very small space, the molecules or atoms would be evenly spaced within that small space. However, if I were to put the same amount of gas into a larger space, the atoms would move out to fill the whole space, but they would also be farther from one another. Okay, so 3 states of matter: solid, liquid, and gas. Now we could do a whole day talking about that, but I'm just giving a really brief overview because what we're talking about today mostly is yeast. So let's go over what we're going to need today for our experiment. So you're going to need something to label your experiments. I have masking tape, and you'll need a pen to write on that. You're going to need sugar, flour, salt, which I seem to have forgotten, but you'll need salt, you'll need some sort of yeast. This is active dry yeast in a powder. It's for baking bread or pizza or lots of other things. And it also comes in packages, but you can also get it in a jar. So you'll need your yeast. You're gonna need 2 kinds of cereal. So I have wheat check and I have some instant cinnamon oatmeal. So those are my 2 cereals. Any cereal you have around your house, pick 2. Maybe pick one that's really sugary and sweet, and then one that's more healthy. That would make a good experiment. And then you'll also need 5 vessels to put your experiments in. It could be bowls, it could be baking tins. I have used jars. It could be any sort of vessel to put your experiment in. And then you'll just need another vessel to put some lukewarm water in. So I have a measuring cup, but you could use anything, any type of cup. Okay, so if you want to pause the video now and get your materials, if you didn't have them ready, go ahead, and if you are ready, let's keep going. So, what do we know about yeast? Do you know anything about yeast? I mean, I feel like before I started baking bread, I didn't know anything about yeast at all. So I wouldn't be surprised if you, like me, had very little knowledge of yeast. Yeah. So yeah, yeast is something that we use to bake bread. What else? What else do we make that needs yeast? That's right. Pizza crust, cinnamon buns, all are doughs that we use making yeast, or all are doughs that we make using yeast. What else can we use yeast for? Yeah, yeast can be used in other types of fermentation. That's right, that's right. I will tell you a little bit about yeast. Yeast is a living organism that is one cell. It's singular cellular, and there are different species of yeast that do different things. We use a specific species for baking, but there are other species that maybe we don't want around because they can cause different types of illnesses in people. So things like candida, which really little kids get occasionally. They're not serious. That's not a serious illness for really little kids, but every so often, babies will get that. So that is also caused by yeast, but a different species than we use when we're making bread. It's in the fungus family. What else do we know that's in the fungus family? Yes, that's right, mushrooms. Mushrooms are in the fungus family too, that's right. And it typically lives, this single-celled organism, in warm, moist environments. So that's, so that's why when we put it in bread dough, you have to use lukewarm water to get that dough to rise. If you go, and this is a secret to making good bread, if you use water that's too hot, it'll kill some of the yeast and not make good bread. So little tip there. It's better to go too cold than it is to go too hot if you're baking bread. So we're going to investigate today, using our experiment, what type of food makes yeast grow the most, and what happens when yeast is exposed to that warm, moist environment, and what its food is. So we're going to pick 3 combinations to test with our yeast. The 3 items that we're going to combine, let me just grab my salt here. The things we're going to combine in different combinations are flour sugar and salt. So I decided to combine sugar and flour, flour and salt, and sugar and salt. But you could pick different combinations. You could try all three. You could try just one and see what you're going to do. So for the sugar and flour mixture, what I did was I took just a teaspoon and put in a teaspoon of flour, a teaspoon of sugar, and then I cut open my yeast packet and put in a bit of yeast. For the flour and salt, I did the same thing. A teaspoon of flour, a teaspoon of salt, yeast, and so on down the line. Then you're going to want to fill your liquid vessel with lukewarm water. And a good way to get lukewarm water is put your finger under the tap, run the water, and when it feels just warm to the touch, that's a good temperature for growing yeast. If it feels hot, that's too hot and it could kill your yeast. So you don't want to do that. If it's just a little warm, that's right. That's just right. Okay. So then you're just going to want to take your liquid, add it to all three of your vessels with your combinations of flour, sugar, and salt. And then you're going to want to wait and see what happens. So I will show you what happened to my combination. I made this chart to track what sort of observations I made about my containers. So let me grab my camera and I will show you close up what the different experiments looked like and how we tracked them. And then after that, we're going to compare our two cereals, but we'll do that last. Okay. So let's look at our different containers. So here's sugar and salt, flour and salt, and sugar and flour together. So let's check out sugar and flour. Sugar and flour, you can see it has a foam on the top, almost like when you pour your soda and it gets foamy on the top. Do you see that foam there? So it's a thick foam on the top of the mixture, made up of really tiny little bubbles. And I will tell you, you can't tell this, but it smells very yeasty. Okay, our next combination is flour and salt. So let's check that out. You can see it's just kind of a lightly colored, light white water. I don't see any bubbles at all. And I will tell you that it does not smell very yeasty either. So let's come to our last combo, which is sugar and salt. And we can see there's a little bit of bubbles. And it sort of is little dots of bubbles, little tiny dots. And I'll tell you that over time, this mixture has gotten more and more bubbly. But at first, it was almost not bubbly at all, whereas sugar and flour mixture bubbled right away. So I've got my three mixtures, and those are my observations. So I'm going to record my observations on this grid. So you can see sugar and flour. I wrote smells yeasty, foam on top. Flour and salt, no smell, no bubbles. And sugar and salt, has a little yeasty smell, and there are strings rising and floating, and it's starting to bubble up. So this is a good way to track our scientific inquiry here. All right, so I'm going to turn my camera back around, and we're going to talk a bit about what we've learned today in our experiment. So when we look at the results of our experiment, what are some theories that we can hypothesize? What are some hypotheses, which is just guesses that may be true, that we could prove true through experimentation? What do we think that the yeast is eating to make these bubbles? We can see that the mixtures sugar and flour and sugar and salt had more bubbles than flour and salt. And which one had the most bubbles of all? Sugar and flour, and the most bubbles of all. So what do we have in common with the two that had the most bubbles? That's right, they both have sugar in them, and then the one with the most has sugar and flour. So our hypothesis then might be something like yeast eats sugar and gives off bubbles. That's right, that's a good hypothesis. And that would be correct. What yeast is actually eating is carbohydrates. So carbohydrates can take the form of the sugars that are in our regular sugar, our table sugar, but it can also take the form of the sugars that are in flour. So carbohydrates that are in the flour and the sugar make a perfect food for the yeast. And what happens is that the yeast eats those and it lets out carbon dioxide. That's what the bubbles are. Can we think of anything else that we eat that has carbon dioxide bubbles in it that helps with its flavor or the way we eat it? Yeah, soda. Soda has carbon dioxide bubbles in it. And so the way that we use that chemical reaction in baking is that the yeast releases a gas, carbon dioxide, which, as we know, right, expands to fill its container, which in baking is all of the little bubbles in the bread are full of carbon dioxide when it's put in the oven. And then when you bake the bread, the yeast dies because it's too hot for it. Has all these bubbles in it. And I'll show you something. I actually had some pizza dough left over that I will show you. So do you see all those bubbles in the bottom of the pizza dough? This is my container with my pizza dough. These bubbles are all full of carbon dioxide. And that's why the pizza dough has that spongy consistency, or bread has that spongy consistency. It's because all of these little bubbles were created by yeast eating carbohydrates and releasing carbon dioxide. Yeah, and humans have figured out a way to make tasty treats out of that. So that's pretty cool. Okay, so let's do our very last experiment, which is deciding which one of our cereals. Now that we know that yeast eats carbohydrates or sugars, we can see which one of our cereals has the most sugar. So how are we going to tell which one has the most sugar? What do you think we'll see in the cereal that has the most sugar? Yeah, that's right. More bubbles, right? So we saw the container that had the most sugars from our initial experiment had the most bubbles. The cereal that has the most sugar in it should probably have the most bubbles. So let's check it out. I'm gonna bring my filming device here over, and we will look at the containers closely. So here are my two contenders. Wheat Chex versus cinnamon instant oatmeal. Let's see which one has the most bubbles. Now on the top, the cinnamon instant oatmeal, it looks a little bubbly. And you can sort of see through there. Do you see those bubbles? It's a bit bubbly on the top. So there's definitely some sugar in that instant oatmeal. Let's check out the Wheat Chex though. What sort of bubbles do we see in the Wheat Chex? Oh, that's really bubbly. That's bubbly all the way down. Do you see all those bubbles? It is so bubbly that this is sort of turned into a gel. This isn't even liquid anymore. It's like a gel. Let's check it out on the top, the Wheat Chex. Oh yeah, do you see all those bubbles? It's so bubbly that it's almost like a gel. And the instant oatmeal, yeah. Oh wow, you see it bubbling there? Yeah, just because I shook it, some bubbles escaped. Wow, look at all those bubbles. There it goes. Ooh, look at all those bubbles. Oh my goodness, look at it go. Okay, so which one do we posit has the most sugar in it? This is a hard question. Yeah, which one do you think? It's a hard guess. They both look pretty sugary. I'm thinking the instant oatmeal though. Did we see all those bubbles? There were a lot of bubbles in that instant oatmeal. So I'm just gonna finish up here by just going back, and we're going over our some follow-up about our yeast experiments today. So in closing, what we learned is that yeast, which is a single-celled fungus, eats sugar, excretes carbon dioxide, and causes, which is a gas, and causes bubbles, which can be used in baking and other types of food production. What's something else that we'd like to explore in this process? Do you have any other things that you've thought of that you might like to experiment with your yeast? Yeah, you could see if I'm right about the water temperature, couldn't you? You could put sugar in a few different containers and try one with really hot boiling water, one with lukewarm water, and one with ice cold water, and see which one bubbles the most, and see if I'm right about the lukewarm water. Yeah, so there's lots of other things you could think of, experiments you could think of to conduct using yeast. So I would encourage you to make some other hypotheses, make up some hypotheses, and design experiments that you can use to test your hypotheses, and then write down your observations. And that is how scientists make discoveries. So thank you for joining us today. Don't forget to sign up for summer learning at smcl.org. And we have lots of STEAM programs, many of which are developed by the Bay Area Discovery Museum, that we'll be sharing throughout the summer. So thanks for experimenting with me. Bye-bye.